Okay, this is Dr. Williamson explaining why lead chloride and other slightly soluble salts are more soluble in pure water than they are in solutions that have a little bit of a dissolved common ion. Here we have pure water, and here we have 0.1 molar sodium chloride. And here I have lead, Roman numeral 2 chloride. That means that this is, let me show you guys. This is made out of lead 2 plus and 2 separate chloride ions. So when we put it in water, solid, it's going to form an equilibrium with lead 2 plus. Okay, plus 2 chloride ions. Okay. Now, if you have a solution that has a common ion in here, meaning common ion means you have a solution that has either lead, Roman numeral 2, or chloride, an ion in common, then according to the Le Chatelier's principle, that's like adding either some chloride ion or like adding some lead ion. And if I add either of those two ions, according to Le Chatelier's principle, adding either of these two ions will shift the equilibrium back this way. Okay? Because increasing this increases the collisions between these two, which increases the reverse reaction rate. Okay? Or increasing this increases the collisions between these two, which increases the reverse reaction rate. And so I'll have more solid and less dissolved ions. That's the correct answer. Another way of looking at it, which is kind of incorrect, but I kind of use it anyway, is I look at it as when I have pure water, okay, let's see here, zoom out a little bit. When I have pure water here, this outside curvy rectangle is my container. These big circles are my water molecules, right? And the spaces in between them are the spaces between the water molecules. And I like to think of that as stuff where the lead and the chlorides get dissolved. So if I represent the chlorides as red ink marks and the chlorides as red ink marks and the lead as purple ink marks. Okay, that's kind of how I'm doing it here. In pure water, I'll have the maximum amount of spaces available between the water molecules to accommodate 1, 2, 3, 4, 5. So I got to have 10, 3, 5, 6, 7, 8, 9, 10. I'll have the maximum amount of space as possible to dissolve as much of this as possible in between the water molecules. No space is taken up. It's not really quite accurate, but that's kind of how I look at it. If I have 0.1 molar sodium chloride, then some of these spaces are already taken up before I even try and dissolve this. And if some of these spaces are already taken up by the chloride in sodium chloride, then I'm going to have less of these be able to dissolve because there's less available spots. Like you show up to a movie theater and many of the seats are already taken. And then you're going to have less seating available for the outsiders to come in and sit down. And that's why having a dissolved common ion already in solution reduces the solubility compared to pure water. Okay, the real answer is Le Chatelier's principle, but that's also another way I kind of conceive of it or conceptualize it. Okay, I hope that helps.